I'm a software developer at Digium. I'm also the software manager for the Asterisk SCF project. I'm going to start taking us into the details here of the actual Asterisk SCF API. Now, when we talk about the API with Asterisk SCF, that term means a lot of things to a lot of different people. But we're talking about, specifically with SCF, are the interfaces between the distinct components. As you've kind of learned about the slice definitions for interfaces and things like that, those definitions are what we refer to as the Asterisk SCF API. There's a lot of reasons for that. You'll see that as you come to get familiar with the system and the paradigms in play, you'll find there's techniques for wrapping a component, basically intercepting calls that are destination to one component just by implementing the same interfaces that it does and then forwarding that message on to the original component, and just providing alternate implementations for components, and just a lot of ways you can customize what we've got here. The API at the global level is kind of structured into 4 categories: the core, system, media, and session communications categories, and we're going to go through each one of those here. Okay, so the core API, these are interfaces and types that we expect to be common to a lot of different domains, not just session communications, and we'll go through each one of these. The discovery API, our discovery mechanism we think is quite powerful. Kevin talked a little bit about ICE Grid and some of the features it provides out of the box with ICE, but we decided that wasn't quite adequate for the kinds of things we wanted to do. So these interfaces here compose most of what you would see in our service locator. And I should point out that the APIs and interfaces that I'm talking about here, it's kind of hard to talk about them without talking about a component that's implementing this interface and exposing it to the system. But there's nothing to say that because we have a component that happens to implement these 3 interfaces would mean that you would have to do that the same way. You could implement a component that only implements one of these interfaces or these and some other interfaces if you wanted to. Back to the API, the service locator interface is the basic way a component does a lookup, a query for a service that it depends on. Service locator management is basically how you register a component. You've got your component, you publish certain capability to the rest of the system, so you register with the service locator via the service locator management interface. And then it will give you back a service management interface, which allows you to manage that object as it exists inside of the service locator component. Some other types that are involved here. The service locator params is kind of the generic way, or the generic pieces of data that go along with registering a component. It's basically a tuple right now, a category, a service group, and a unique ID. You can extend that. You can subclass the service locator params and add additional information. And you can also, for a given type of service, you may choose to register your own logic that does the decision about which service is going to be returned to somebody who's doing a lookup on that service. It's just a simple interface, is supported. It takes in a service locator params, and you can do the decision logic and return back yes or no, this is the right component to use, or right implementation, or proxy. Well, it ends up being a proxy, so don't want to get too far in the weeds here, but yeah. All right, the endpoint API, there's only one interface in there. It's base endpoint. We talked about the kind of limitations. The reason it's called base endpoint and not just endpoint is because the namespace was endpoint and slice, as we were talking about, those kind of little limitations. You can't name a class in a namespace the same as the namespace, so it's the base endpoint. So you'll see that session communications extends this type and adds additional information to it. We expect other endpoints besides session communications instances would be for presence messaging and other types of communication technologies that are added to Asterisk SCF in the future. All right, routing. The routing API is all about finding endpoints. So endpoint represents, some endpoint of communication. So our termination point for communication. The endpoint locator interface is how you do a lookup. So in our case, the SIP session gateway manages a collection of SIP endpoints. So it provides an endpoint locator interface to the rest of the system. But you wouldn't want everybody in the system to have to know about every type of session gateway there was. You wouldn't want to know, okay, I've got to go check the ISDN gateway. I've got to go check the SIP gateway to find this endpoint. So we have a locator registry interface. So the SIP session gateway pushes his endpoint locator interface into this locator registry, and it kind of centralizes that whole process. So, for example, our routing service provides this locator registry functionality for our system. Any questions? All right, so that was it for the core API. Now we'll switch over to the system API. Here we're talking about the interfaces, the types that help a component become part of the Asterisk SCF system. Okay, so the component interface, or the component namespace, provides us the component service interface. That's basic life cycle management of a component. Be able to pause it, resume it, tell it to shut down. There's a component test interface. It provides a real simple abstraction for putting a component into a known state for testing purposes. This particular interface is an interesting case where we don't register the component test interface with the service locator. It uses a mechanism known as facets. So what you do is it's a facet of the component service interface identity. So you basically ask the routing service, the service locator for the component service interface, and then you cast it using an ICE cast operation to a component test interface. And if that component supports the component test interface, it gives you that. So let's see. And then the replica interface lets you put a component, switch it between active and standby mode if it's part of a replica group. The components, Josh will probably talk later about this, but when the components come up, they're in a standby mode by default. So they have to be told to become active. All right, configuration. So here we get to some of the stuff that Josh actually already got into a little bit. The configuration service is an interface for pushing. And if there's any of these interfaces you want to look at, I'm not trying to show the slice on here, but I can jump down and pull up the slice interfaces for anything anyone would like to see. The configuration service is an interface for pushing the configuration data into a component. We also have a configuration replicator. So if you have some components that are participating in a replica group, you wouldn't want to have your configuration component or configurator pushing to every individual one and knowing about their existence. So basically, you have its state replicator register as the configuration service for that replica group. And when someone goes to the service locator, gets that interface to push config data, the state replicator knows about everybody in that group and forwards all the configuration data for them. Some of the key types in here are the configuration item. That's a single configurable value, something like an IP address or something like that. Configuration group, as the name sounds, it's a group of items. And then one of our extensions to ICE that's probably been mentioned very briefly, we can tag a type as we have some extensions to the slice definition and the slice compilers where we can code generate a visitor implementation for any type. And what this does in the configuration case, it makes it very easy for you to iterate over configuration data that's being pushed into you by there's a visitor already implemented for you, so all you do is implement the basic callbacks for each one of the visit methods for those items. Let's see. Okay, so I think, Alex, you were asking about what kinds of things were configurable, and SIP endpoints are configuration groups, and so things like the formats to use in communicating with a certain endpoint or a port to contact it, all that can be set via configuration in the SIP session gateway. Items. Yeah, a configuration items is like a scalar, but the configuration group is some group of such things. Yeah, you actually, into the configuration interface, you actually push in a sequence of configuration groups, a collection of groups, basically. So, all right, now we go to the hook category in the system API. Basically, it's just a couple of real low-level types here, and they exist for a pattern that comes up in several places in Asterisk SCF. A hook is basically an encapsulation of some logic that you want to insert somewhere into an Asterisk SCF component. An extension point is a place in the component that will make use of a hook and provides an interface for you to set the hook. So we'll see an example of that later on when we go through the call sequence. But that's basically what this is. Now, this is one area of extensibility within Asterisk SCF that we kind of have to bake into each component and figure out where would an extension point be logical in this component, and then the developer will provide the extension point for someone else to come along and insert a hook into it. Yes? Let's see. Let's see, is that in the examples repo? Yeah, I think so. Okay, but I do have the example stuff. Yeah, okay. Yeah, I'm going to go ahead and bring up. Don't hate me because I'm beautiful. Hate me because I use Visual Studio for development. So I'll have this up so we can get to things quickly as well. So here's actually some of the service management slice definitions right here. But enough of that. Back to the presentation. The logger. The logger interface, there's a logging server interface. This is so that we can do logging to a centralized component. And I won't go into this in any detail because you really don't need to know this interface, because we have a logging client class which just makes everything really easy. You just include the header, link with it obviously, and then you use the factory to create one, and then you just use it anywhere you need to log. About the only thing you really need to know is the logging levels and their impact on how much information you're pushing across the network to do logging. Okay, let's see. Okay, so here's a special case where we define some slice for the thread pool and the work queue that have nothing to do with anything that's going to be transmitted over the wire, not going in between. So it's kind of the exception to the rule that I said earlier about what the API really was. And the whole point of this is so that we can encourage some paradigms. When right now we're developing everything in C++, other people we expect to come on board and start developing in other languages that they prefer, whether it's a new component that we haven't thought of or some alternate implementation of some component we've built, or something like their own custom routing service. By defining these kind of concepts in the slice definitions, that kind of paradigm, which we know is going to be useful no matter what object-oriented language you're programming in. It kind of fosters the use of that same concept so that if you come across some component written in another language, it's not a total foreign concept that you're coming up on. And that's it for the API overview.